Hello and welcome. Today we're going to look at the topic called waves. Our objectives in this video is going to be firstly to know that transverse waves transfer energy without transferring matter. Secondly, describe what is meant by motion as illustrated by vibrations in ropes, springs, and by experiments using water waves. Thirdly, to know that a transverse wave, the direction of vibration is at right angles to the direction of the propagation, and understand that electromagnetic radiation, water waves, and seismic S waves, secondary waves, can be modeled as transverse. Then know that a longitudinal wave, the direction of vibration is parallel to the direction of the propagation, and understand that sound waves is seismic P waves, that sound waves and seismic P primary waves can be modeled as longitudinal. So here on this simulation we are going to illustrate a wave today. I'm going to teach you all the basics about waves. So what we see here is a chain of particles, green and red balls. We've got something here on the right that can make a pulse, and so the position where all of these red and green balls are, we call the undisturbed position or the equilibrium position. You're going to notice when I make these particles move that there's going to be a dotted line. Secondly, we call these dotted things a medium. Now, a wave is the transfer of energy through a medium. Okay, so if I do this, I create a disturbance in my medium. So I transfer energy by making the medium move up and down. I make a disturbance and I transfer energy, and that energy is carried along the medium as the particles pass the energy on from one particle to another. So this is called a pulse. This is a single disturbance of the medium. Then what we are transferring in the medium is energy. So by making this pulse, I'm using energy, and this energy is transferred from one particle to another. Now next I'm going to show you a wave. Now a wave is a continuous rhythmic disturbance of the medium, and now we can see that the medium transfers this energy from left to right. So let's just go through those words again. We have the word medium, substance through which energy is transferred; a disturbance, a way of transferring energy; equilibrium position, position where medium is found undisturbed; pulse is a single disturbance of the medium; and a wave or oscillation is a rhythmic continuous disturbance of the medium. Now we're going to look at a transverse wave. Before we start with that, we need to understand that Latin roots for the word transverse means across, and a transverse wave is a wave where the direction of the disturbance is perpendicular to the direction of energy transfer. Now this is an example of a transverse wave. Do you notice that the thing creating the wave is moving up and down, but the energy is moving from the left of the screen to the right of the screen? This is an example of a transverse wave. We can demonstrate this on a rope, on a string, in a chain, and it's a lot of ways. On water we can also see this happening. So this is a transverse wave. The particles individually move up and down. If you look at any of these particles over here, let's follow one of the green ones, you'll see that they just move up and down. Okay, but the wave is moving from right to left, so that means it's moving perpendicular to the direction of energy flow. Next we will be looking at a longitudinal wave. Longitudinal, the Latin meaning is alongside or parallel. So a longitudinal wave is a wave where the direction of the disturbance is parallel to the direction of energy transfer. Now in this simulation, what you will notice is a longitudinal wave. The particles in this case is moving in the same direction as the energy. We can see that the energy is transferred from left to right. And if you keep your eye on the red line or on the green line, you'll see that they actually move sideways, left and right as well. Now this is an example of a longitudinal wave. Now this is typically the way you hear the sound waves from your device coming to your ear. The air molecules bump into one another, transferring the energy all the way from your speaker to your ear. Also another example is seismic primary waves, which also in an earthquake transfers the energy like this through the ground. Thank you very much, and hope you learned something. Stay tuned for my next video where we're going to be looking at the next section. Thank you.